So in this video, I'm going to start talking about rook polynomials. Okay, so this is a thing to do with matching problems, as we've been discussing recently. In this topic, we're going to always draw our matching problems in the kind of chessboard style. So typical version is like this. I'm going to do here a 3x3 chessboard and block off the top right corner. And so, if you remember, the way we sort of think about matching problems in terms of chessboards, we're trying to place rooks or other kind of markers. I'm just going to draw circles because I can't draw rooks very well. You want to place circles on this chessboard in such a way that you never have two markers in the same row and you never have two markers in the same column. So one way we could do it here, for example, we can put a marker here and a marker here and a marker here. Okay, so now we've got three markers on this chessboard, so you never have two in the same row, you never have two in the same column, so that's an admissible placement of rooks. So one thing we could do is we could try and ask ourselves how many different ways there are of placing rooks on a given board where some of the squares are blocked off. So if we go back, let's draw this again, empty. Okay, and so let's ask how many ways are there of placing some rooks on here. Okay, well, suppose we just want to place one rook. Okay, if we place one rook, then this issue about not having two rooks in the same row or not having two rooks in the same column, that just happens automatically. There's nothing going on there. So we just get to place one rook in any one of these squares. How many are there? 1, 2, 3, 4, 5, 6, 7, 8 squares. Okay, so we can say placing one rook has precisely 8 possibilities. Okay. Now let's try and place two rooks. Okay, so we need to be a little bit more systematic if we want to start talking about that. So let's our usual way we'll do this is we'll label the rows A, B, C, D, etc., and the columns 1, 2, 3, etc. And now we want to place two rooks. Okay, so what we're going to decide. So firstly, we place the first rook, and that can go. Actually, so let's go back to the one rook thing. We can now we can list these more explicitly. Okay, so we can have an A1, we could place a rook there, or A2, rook there, or B1, B2, or B3. Okay. Not allowed A3 because that's the one that's blocked off. We can have B1, B2, or B3. We can have C1, C2, or C3. Okay, so there's our 8 possibilities. Now let's think about two rooks. Okay, so there's a bunch of different ways we could do this. Okay. Let's suppose we place the first rook at A1 here. Rook here. Then where does the second one go? You see, if we place our first one here, then different colour. So now we're not allowed to place one here anymore, or here or here. Right? Those are blocked off because they're in the same row or the same column. So our second one, it could go in B2 or B3. So let's say, or C2 or C3. So we could have A1, B2. A1, B3, A1, C2, or A1, C3. Those are all the possibilities if we started by putting a rook at A1. What if instead we put a rook at A2, okay, as our first rook here, then where could, let's maybe draw that again. So now we put rook here at A2, and then now there's some other places blocked off that we're not allowed to use. Okay, but still we've got now four different possibilities for the second rook. Okay, so this one is here. So draw the labels in again. Okay, so now we're at A2, and then we can go to B1 or A2 B3 or A2 C1. A2, C3. Okay, And so there's those possibilities. So that's everything that can happen if we start with A1 or A2. And alternatively, we could start with B1. Okay, then so we're saying B1 is going to be the first rook, so we don't have any in the top row. We've just got our first one here is B1, and then we can't do B2 or B3. The other one has to go C2 or C3. So we can have B1 C2 or B1 C3. That's or alternatively, our first rook could be at B2, and then if we go to B2, then you get two choices for a rook in the next column. You get B2 C1 or B2 C3, or we could start with B3. And if you start with B3, then you can have a C1 or a C2. Okay, so those are all the possibilities for two rooks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 possibilities. And what about three rooks? So again, that's a similar kind of analysis, right? Let's suppose we start by putting in an A1. Then if we've got three rooks, you see there has to be one on each row. Okay, so we've got to have an A and then a B and then a C. So we've got A1, then you can then go to B2. Let's draw the picture here again. Here we've done an A1 and a B2. Now, to avoid any clashes, we're not allowed to go here or here or here or here. There's only one possibility left for where the third one has to go. It has to go there. So then you get A1, B2, C3. That's one possibility. Or we could have, instead of going there, we could have gone there. So we could have A1, B3, and then you're forced to do C2. Or you could do A2, B1, C3, or A2, B3, C1. A2, B3, C1, like so, let's say. And then you can't do A3 because A3 is blocked off. And these are the only possibilities, right? You have to have, your first one has to either be A1 or A2. You have to one in every row, so it's either A1 or A2, and then we've seen that these are the only possibilities there. So we've got four possibilities. Okay. So that's what we do for 1, 2, or 3 possibilities. And you could also think about placing no rooks. And this is kind of a little bit funny to think about, but it turns out that the right way to interpret it, I mean, there's precisely one way. You don't have to make any choices. You're going to place no rooks, so there's nothing to do, no choices to make. So let's just get one way to do it. Okay. So so these are all our possibilities. And then it turns out, for reasons that will become apparent later, to be good to sort of combine these numbers together. Okay. So we've got this 1 here, 8, 14, and the 4, and okay. And so we define the rook polynomial which is going to be called RB of t. Okay, so this board here, we're going to call it B. Okay, so RBT is going to be these numbers here times the corresponding powers of t. So you get this 1 times t to the 0 for that, plus 8 here times t to the 1, plus this 14 times t squared. You see that's for 2 rooks, so you have the power 2 there, and 4 possibilities for 3 rooks, and so that's 3 rooks, so that counts as t cubed. So that's what we're going to call the rook polynomial for this board.